Hello everybody. I can prepare for my exponents test by practicing. There's a lot to get through here, so let's just get right to it. If you have a fractionals, exponent, or radicals question that's multiple choice, use your multiple choice strategy. So I'm going to store my 10 for x, my 15 for y. I don't need that for this particular question, but I like to get in the habit of doing that. I type in my original problem, x squared over x to the 1/3 to the power of negative 1/2 0.146 ... Let's jot that down. I type in each potential answer. Just make sure to keep the negative away from the root. Whenever you have a root, if there's something in front, put the root in parentheses. I'm going to jump right to the correct answer, which happened to be choice 2. Alpha x 1 over. Just type in the 6th root. Alpha window, option 6. I can type in whatever root I want. 6th root of x to the power of 5. I get the same 0.146 ... That's my answer. Nothing new. We've been doing that strategy for a while. A lot of strategies for the multiple choice, including number 3. This is a throwback, a radical equation. But if it's an equation and it's multiple choice, we're going to take each answer. We're going to substitute it in. I like to do it with storing. I'm going to start with choice 1, negative 3. I'm going to type in the left-hand side, second radical, 3x plus 16. I'm going to type in my right-hand side, x plus 2. Do they match? Nope. So that one can't be the answer. Let's just jump right to 3. 3 store as x. I already typed in the left and right-hand side, so I can copy and paste them. That's my left-hand side. That's my right-hand side. 5 equals 5, so 3 works. Choice 2 is saying that 3 and negative 4 are the answers. So now I'm going to store negative 4. I'm going to type in the left-hand side. I'm actually just going to copy and paste it. I'm going to type in the right-hand side. Do they match? No. So negative 4 is out. My answer is choice 3. Do not do the algebra. If it's an equation, just take each answer, substitute it in, with storing or without. This is literally the exact same thing. It's another equation. I don't care what it looks like. We're going to store each potential answer, and we are going to type in the left, type in the right, and see if it works. I believe the answer is choice 4. I'm not 100% sure. Alpha x ln 6 over ln 2 minus 4, store as x. I don't care how they give you your potential answer. You store it. Type in the left-hand side, 6 parentheses 2 to the power of x plus 4. My right-hand side is just 36. Does my left-hand side equal my right-hand side? Yes. 36 equals 36. Any equation, store each potential answer, type in the left, type in the right, see if it matches. I stored choice 4. I typed in the left, I typed in the right, I saw if it matched. It did. That's my answer. All right, we get to some real math. No more strategies. You need to know what exponential growth looks like. And you need to know what logarithmic growth looks like. Exponential, logarithmic. Exponential has a horizontal asymptote. It goes through 1, 0. It looks like that. Logarithmic has a vertical asymptote. It goes through 1, 0. It looks like that. So if I'm looking at this thing, choice 1 is exponential, and choice 4 is log. The other ones are inverted versions of those, but really the most thing you're responsible for knowing is your growth. Now, it's asking for the inverse of log. You need to know that exponential and logarithmic are inverses of each other. The inverse of exponential is log. The inverse of log is exponential. So if it wants the inverse of log, I'm looking for exponential, which is choice 1. Inverse and logs are inverses, exponents of logs are inverses of each other. You need to know what they each look like. So if they're asking for the inverse of log, you're looking for the exponential. If they're asking for the inverse of the exponential, you're looking for the log. Which statement about the graph is true? The best way to do this is to type it into the calculator. When it's being transformed, it can get a little tricky. So I've got 2 to the power of x minus 1, 2 to the power of x minus 1. Let's look at the graph first. It's always increasing or it's always decreasing. That thing is always increasing. So the decreasings are out. The y-intercept is 0 or the y-intercept is negative 1. Just by looking at it, I can see that the y-intercept is 0. I could also go to the table. The y-intercept is when x is 0. When x is 0, y is 0. It's not going to always be the case that the y-intercept is 0. Just look at it. Y-intercept is 0, always increasing. Take a look at it. Shouldn't be hard. 11. We're talking about end behavior with exponential. You don't need the calculator to do this, but it will be helpful. 3 to the power of x minus 1 plus 2. Graph. As it approaches positive infinity, as it goes to the right, it's going up to positive infinity. As it goes to the left, as it goes to negative infinity, it's approaching the asymptote. The asymptote is the vertical shift. It's also the value, the cheat is it's the value that you see repeated in the table. It's never actually hitting 2, it's just getting closer and closer and closer. Either way, the asymptote is 2. So as x approaches negative infinity, it approaches the asymptote, which is 2. Doing an actual graph, keep it simple, type it into the calculator, plot the points. You do need the asymptote. The asymptote might not be a bad idea to do first. For exponential, the asymptote, since my basic growth exponential graph looks like this, and this is your asymptote, the asymptote is going to always be the vertical shift, which in this case is negative 8. So my asymptote is going to be y equals negative 8. If that's too much for you, again, what we just did, 2 times 3 to the power of x plus 1 minus 8. Go to your table. It's that repeated value. You see the negative 8, negative 8, negative 8. That's your asymptote. Now I want some more nice points. Only your nice points. I don't want your decimals. I see negative 1, negative 6, 0, negative 2, 1, 10. Negative 1, negative 6, 0, negative 2, 1, 10. To graph anything, just type it into the calculator. Your asymptote is a dashed line. We're going to use that to guide our graph. Negative 1, negative 6, 0, negative 2, 1, comma 10. You can get closer and closer to the asymptote, but never touch. Arrows, arrows. Follow-up questions. Domain. Any exponential graph is always negative infinity to infinity because there are arrows pointing to the left and to the right. Range is going to always have the asymptote as one of its values. From bottom to top, it's starting at negative 8, not including negative 8, and it goes to infinity. We already talked about the asymptote. As x approaches negative infinity, as I go to the left, the graph is approaching the asymptote, which is negative 8. As x approaches positive infinity, that's to the right, the graph is pointing up. That's positive infinity. Log graphs have vertical asymptotes. Since I know that the parent function looks like this, the horizontal shift will be the vertical asymptote, which is left 2, which will be x equals negative 2. There's also a cheat for this. y equals, first of all, to type in log base, alpha window 5, log base 3, x plus 2 minus 1. Go to your table. The last error, that's your asymptote, and as you see, your last error is -2. Other than that, just find some nice points. I see -1, -1, 1, 0. Usually you get 3 or 4. However many there are, then use them. I see 7, 1. That's going to be it. So x equals -2 is my asymptote. -1, -1, 1, 0, 7, 1. Getting closer and closer, but never touching. Make sure you put arrows. Domain is going to always be from left to right, so it starts at -2, but not including -2, to infinity. The range is pointing down and up, so that's -infinity to infinity. Asymptote we got. As x approaches -2, the graph is pointing down. That's -infinity. As x approaches positive infinity, as I go to the right, the graph is pointing up, positive infinity. Radicals are fractional exponents. Rewrite the radicals as fractional exponents. If there is no root, the root is 2. And if there is no power, the power is 1. Get rid of parentheses. Nope. Negative exponents are fractions. Nope. Clean it up, MD. M, do I see multiplication? Yes. When I'm multiplying, I add my exponents. I do not trust you adding exponents. So, sorry, that's just the truth. Use the calculator. You can do what we did in middle school. I know we went over an example of it. Finding a common denominator and all that. I would keep it simple. 19 over 6. So that becomes x to the 19 over 6 over x to the 1 over 6. Now I'm dividing. When I divide, I subtract 19 over 6 minus 1 over 6. There is a common denominator, but if that's still too much for you, that's okay. 19 over 6 minus 1 over 6 is 3. X to the third is the answer. 19 and 20, it wants you to express your answer as a radical. Well, radicals are fractional exponents. Nope. Get rid of parentheses. Yup. Everything inside gets it. So it's 16 to the 1/4. X to the 4 times 1/4. 4 times 1 is 4. Over 4 is 1. Negative exponents are fractions. Nope. Clean it up, MD. I can evaluate the 16 to the 1/4 power. Power over the root. The 4th root of 16 is 2. You can use a calculator for that as well. 2's are going to cancel. I'm dividing. When I divide, I subtract 3/2 minus 1. Again, you can use a calculator for that. 3/2. Or you'd have to find a common denominator, is 1/2. So I have x to the 1/2. And since it wants the answer as a radical, radicals are fractional exponents. I pop it back into the radical. I don't have to write the 1 and the 2, but I'm going to, and that's my answer. It's giving me an equation. It's telling me that A of t is the amount, T is years. It's giving me 50 grams. That's A of t. So I'm going to replace A of t with 50. So instead of A of t equals 50 equals 200.094 to the 2t. Now I have to solve the exponential equation. Step 1 is to isolate. 50 over 200 is 50 over 200. It'll reduce the fraction for you, 1/4. equals 0.094 to the 2t. And now that I'm isolated, I take the log of both sides. The reason I do that is the exponent comes to the front, so it becomes log of 1/4 equals 2t log of 0.094. Divide by 2 log 0.094. Divide by 2 log 0.094. I type that into the calculator carefully. Put that in a great spot. There we go. Alpha x log alpha x 1/4 over 2 log 0.094. It says to the nearest hundredth, that would be 0.29. To solve an exponential equation, we isolate by dividing, and then we take the log of both sides. The exponent comes to the front. This is your Newton's law of heating and cooling. The math is essentially the same as what we just did. You just have to be careful here. Read it carefully, one piece at a time. Empanadas are taken out of an oven when they reach the temperature of 168 degrees Fahrenheit and put on the kitchen table at room temperature. So they're coming out of the oven. So this 168, this is your initial temperature, and this 68, this is your surrounding temperature. So your initial is 168, and your surrounding is 68. After 8 minutes, that's little t, the temperature of the empanadas is 125. That's capital T, the temperature after time passes. Algebraically determine the value of K. All right, so I'm going to give myself enough space to do this here. I've got capital T is 125 equals TA is 68 plus parentheses T0 minus TA. E is E to the negative K is what I'm trying to find. T is 8. Now, to solve the equation, I isolate. I always add or subtract first. 125 minus 68 is 57. 168 minus 68, I'm not going to use my calculator for that, that's 100. E to the negative 8K. I'm not isolated yet, I divide by 100. Sorry, some technical difficulties there. As I said, we divide by 100. Oh, we have more technical difficulties. No, we don't. Divide by 100. 57 over 100 is 57 over 100 equals e to the negative 8k. Now that I'm isolated, I do log, or in this case, ln of both sides. You can do log of both sides, but ln is easier because it gets the e to cancel. So I have ln of 57 over 100 equals, the negative 8k comes to the front, negative 8k ln e. The reason I do that is ln e cancels. I divide both sides by negative 8. I go to my calculator. I've got alpha x ln alpha x 57 over 100 over negative 8 is 0.070. That's my value of k. Now there's more. That's the first question. So I got my 0.070. I'm up to there. Now I'm going to erase all this because there's another question. I'm not going to forget that my k is equal to 0.070. I'm going to rewrite everything. t, little t, ta, t0, k, I didn't forget that k was 0.070. Now, it says to algebraically determine how long it will take for the empanadas to reach 100 degrees Fahrenheit. So that's the temperature after time passes. It's asking for the amount of time that's passing. The surrounding temperature hasn't changed. The initial temperature hasn't changed. So now I'm substituting into that formula again, and I'm literally doing the exact same thing. I've got t, 100 equals ta, 68 plus t0, 168 minus ta, 68, e to the negative. Now k is 0.070, and little t is what I'm trying to find. I'm doing the exact same thing. I'm solving the exponential equation by isolating. 100 minus 68 is 32, equals 168 minus 68 is 100, e to the negative 0.070t. I'm not done isolating yet. Divide both sides by 100. 32 over 100. It's going to reduce to something. 32 over 100. 8 over 25 equals e to the negative 0.070t. Now that I'm isolated, ln of both sides. The reason I do that is that comes to the front. ln 8 over 25 equals negative 0.070t. ln e cancels. Divide by negative 0.070. Divide by negative 0.070. I type that into the calculator. Alpha x, ln, alpha x, 8 over 25 over negative 0.070. It wants it to the nearest minute. That is 16 minutes. By the way, another option, now again, it says to do it algebraically, but if that's not working for you for whatever reason, we could always do y1, y2 intersect. I can go to my calculator, I can type 100 into y1, I can type 68 plus 168 minus 68. E to the negative 0.070x. Zoom 6 isn't going to give me anything. Since I have my y1 as 100, it's got to be more than 100. So I'm just going to adjust my window and make my y max 150. Let's see if that does anything for me. I need to see more of the right, so I adjust my x max. I'll make it 30. Graph. I see my intersection. Second trace. 5. Enter, enter, enter. X coordinate, X coordinate. You see I get that same value. On this test, you're not getting full credit for that, but you would get some credit for that. On the regions, sometimes it doesn't say algebraically. So if you do it graphically, you may be able to get full credit. If not, you'll be able to get partial. That's not the objective, but it is something you have as a backup. Which brings us to the final type of question. I don't feel like doing this, but I might do it anyway. Little typo there. This should have said 90,000. To graph anything, and it tells me to graph between 0 and 10, I'm going to just type it into my calculator. Just like the graphs or the logs and the exponentials. This is technically an exponential, it's just a little bit more to it. 90,000.887 to the power of x. 18,000 1.152 to the power of x. Table, it says it wants me from 0 to 10, so I'm going to write v of t. I don't need to write every single point. I'll just go 0, 2, 4, 6, 8, 10, and m of t 0, 2, 4, 6, 8, 10. And I go to my table and I write down my values. So for the blue, 0 is 90,000 and 18,000. 2, I've got 7,809. And I've got 23,888. 4, I've got 55,710. And 31,702. 6, I've got 43,831. And 42,071. 8, I've got 34,485. And 55,833. And 10, I've got 27,132. And I've got 74,096. Because it gave me an interval to graph it over, no arrows. I got to set my graph up. Because I have 20 boxes on my X, I'm just going to go every other box. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because my highest Y value is 90,000, you can kind of just guess and check numbers to come up with how much you want each box to be worth. I'm thinking every other box to be worth 10,000 would be perfect. So that's every box is worth 5,000. So that's 10,000, 20,000, 30,000, 40,000, 50,000, 60,000, 70,000, 80,000, 90,000, 100,000. I plot my points. 0, 90,000. 2 is a little bit above 70. 4, 55. 7, 10 is a little bit above 55. 6, 43 is a little bit above 40. 8, 34 is just under 35. 10, 27 is between 25 and 3,000. Again, no arrows since it told me to graph between those two values. That's V of t. Now, M of t, 0, 18, that's under 20. 2, 23 is a little bit below 25. 4, 31, a little bit more than 30. 6, 42, a little bit above 40. 8, 55, just above 55. 10, 74, a little bit less than 75. Again, no arrows because it's said to graph between 0 and 10. That's M of t. It's a bit tedious, but it's not hard. I did it. All right, now some follow-up questions. The first follow-up question is almost always equal or same or M of t equals V of t. Intersection to the nearest tenth of the year. So, second trace, intersect. I don't already have it. I can cheat off of my graph here. Since the x values are going from 0 to 10 and the y from 0 to 100,000, I'm going to input that into my window. My x is going from 0 to 10. My y is going from 0 to 100,000. Enter. Second trace. Intersect. Enter, 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 x value, x value, x value to the nearest tenth, 6.2. So t equals 6.2 years. Then it says Tom will open a new bank account when the value of his account is 25,000. Value of his account. This is the value of his account. If we look back, the value of his account is V of t. So it's telling me that V of t is equal to 25,000. So I'm going to substitute that into the V of t equation. So it's going to be 25,000 equals 90,000.887 to the t. And now I solve this algebraically by isolating and logging both sides. 25,000 divided by 90,000. It's 5 over 18. So I have 5 over 18 equals 0.887 to the power of t. Log of both sides, log of both sides. I've got log 5 over 18 equals t log 0.887 divided by log 0.887 divided by log 0.887. Let the calculator do the work for you. Alpha x log alpha x 5 over 18 over log 0.887 to the nearest hundredth of a year. I don't know what I just did to this thing. 10.68. So it's a long problem. It's really not hard. The test in general, some of the stuff you can use strategies. You got to know how to solve an exponential equation. There's going to be word problems. You're going to have to read carefully. But everything you need to know how to do is here. Practice it, and then practice some more. Goodbye. Bye.